We saw in example 1 where we had one rater rating each individual. Now we want to know in example 2 for the design 2 in our textbook starting on page 166, what will happen if we have two raters doing this. And we can see here the difference in our generalizability coefficient. This was our generalizability coefficient of 0.74 or 0.75 in your text, rounded up. And in example 2, we can see that we have a larger reliability coefficient. And part of the reason why this sort of makes sense, if we have multiple raters rating each person. So in our textbook example, we have each examinee is rated by several raters. All raters rate each examinee. So we have a lot of overlap going on in this model, and we can see that in design 2, when we take a look at what's going on mathematically, we can see we still have person variance in the numerator. Remember, we're taking that amount of person variance, that amount of, we're sort of thinking that as true variance, true person variance, and we're dividing that up by both person variance plus some other thing, and in this case, the other thing is everything else related to persons for this generalizability coefficient, which is our error. And we take that error of 1.044 in the denominator. Instead of technically in the first study it was divided by 1, now we're dividing it by 2, so there's less error in the denominator, which gives us a greater value for our coefficient. In study 3, so just to remind you, in study 3, each examinee is rated by a different rater. There is only one rater for each examinee. So this means that we have, if you just sort of think about what you would expect the reliability is without going into mathematics, you've, especially from design 2, we've gone down one rater, and from design 1, previously we had each examinee is rated by one rater, and that rater rates all examinees. So the same person rating everyone in design 1. Now you have a different scenario, and this happens a lot of times in classroom settings where you have a teacher evaluating their student, and you're comparing it to another teacher evaluating their student. So this is sort of still sticking with our essay example from the textbook. And we can see reliability has gone down to 0.68. In some ways, this is a more financially viable experiment, but reliability has definitely taken a toll here, and we can see why when we look at this. In thinking about what the differences are here in design 2, this is very, very similar in so many ways to the difference between an absolute and relative example here. We can see in the denominator now that that coefficient includes a term for person in the numerator still. All these have the person in the numerator. They're sort of the true concept of variance. To relate it back to classical test theory, there's the universe score for persons. And then we divide it by persons. Still by error, we can see that that value there's of 1.04, B16 is still in there. And now we have to divide it also by the rater error. Think about the raters, they also have their variance components, they also fluctuate, so that adds more error into the denominator. So that we not only have the error of persons and the error, residual error in our denominator, but now we have to say, well, each person is rated by a different rater. We have to account for that in this model. And finally, in design 4, in this design, if you recall, we have each examinee is rated by several raters. There are different raters for each examinee. So it's an extension of D3. D3 started on page 169. Started on page 168 and continued on 169 where we have the equation of 8.15. Now we're going to use equation 8.18 on 169, page 169. We see now we've gone from one rater per person, and each person has their own rater, to now two raters, and we see an increase in that reliability coefficient. And maybe as you've expected, we're dividing by 2. In this case, though, we're taking, I'll walk you through this, we have the universe score, or you can still think of this, if it helps to start, sort of that which is truth, in a sense about persons. That's what we know to be truth from the G study, which is, remember, truth with a little t. That is, the variability of persons is still in the denominator. Then we're dividing it by the variability of persons, the variability of raters, and the variability of error. But now we're taking those last two components and we are dividing it by 2. We're taking away everything interacting with raters in that denominator. And we're saying, well, now that there's 2 raters, we're going to reduce the error based on raters. And everything that interacts with raters, we divide by 2. Just to emphasize for the D study for 1 and 2, in the D study for 1, we went through and we got a generalizability coefficient, and this is a relative coefficient, and we went through and we took person variance and divided by everything that had to do with persons. That is, we took this variance of 3.089 and we divided by 3.089 plus error, because error is entangled with person. In an absolute study, if we were making more of a criterion reference choice in the next chapter, we would be taking all of the components. So not just everything intertangled with persons, but everything, and using that in the denominator. And we can see the same is true for D study for 2. We can see that we're taking the variance component and we're dividing it by everything in the denominator. But just like in the generalizability coefficient for design 4, everything that has to do with raters, because we have 2 raters in design 2, is divided by 2. And this is reflected in our equation here. We went over all of these in class. There's a few things we didn't go over in class on this sheet, so you have this sheet to follow along with. I just do an example for you all to play along with, where I took the items we've used earlier, and these are just 6 items. I ran them analysis of variance in SPSS, which you're welcome to try and practice. Just copy these yourself and practice this. And I got these variance estimates, and I use these various estimates to calculate both absolute and relative coefficients for this set of items. In class, the other thing that we did is we went through the Webb and Shevelson example. That short 2-page paper that I handed out to you is a great example to help you out understand differences between G and D studies and some of the elements about universe scores, etc. And here I've just gone through and I did the calculations for us. I took the variance components from the text and I just did some calculations. In this case, you can see that I take everything that is, in this case, absolute in the denominator, and here everything that is relative in the denominator. In class, I talked about this as everything that had to do with P, and that G study, the G coefficient, that's very similar to our alpha value that we would get in classical test theory. And the absolute decision is more of a measure that would be very useful in a criterion reference test where we have to make a decision about an individual. And I will stop the video here and let you guys go through. Hopefully you'll go back through some of these examples yourself. So the idea is just to represent this to you that we had in class, and that you can go through and pause the video as you want and practice these. You have this Excel spreadsheet, and if you have questions, you'll send them to me, assuming you're one of my students in my class listening to this video.